Okay. So as he said, my name is Ater. I'm from Tel Aviv, Israel, and I'm going to talk to you today a little bit about the Dev Foundation and what it is we're building. And actually, before I stepped here, before I started this talk, I was speaking with one of the other speakers, Tejas, and he asked me what my biggest fear is before this talk. And I said, because I'm speaking about our startup and not talking about code, I don't want people to think I'm here to sell you something or convince you or recruit you. This isn't what this is. It's just an interesting story about our journey and what we're trying to build. So let's get to it. I'm going to start with a very dry clinical explanation of what it is we're building, and then it's going to get really interesting really fast. There's going to be autonomous drones delivering pizzas. There's going to be cars talking to other cars, maybe even some code. But first, since we're going to be spending the next 20 minutes together, let me introduce myself a little bit. I have been writing code since I was 8 years old. It's what I love doing most. And my career has taken me throughout different startups. And in each startup, I found myself being very, very hands-on at the beginning. And as time passed, I found myself drifting further and further away from the code, which is what I love doing most. So it was then that I found open source. Open source was the perfect way for me to continue to write code outside of my work while still writing code that was interesting and meaningful to a lot of people. I actually remember the first time I had a pull request accepted and merged to a major open source library. This was in 2012. I refactored one of the functions in _JS. And when I found out my pull request got merged, I was alone at home and I started jumping and dancing badly in the room alone, on my own, dancing because a few lines of code that I wrote that determined finite numbers got merged. So I think that tells you all you need to know about me and what excites me and what drives me. So if you look at this grid, you probably know this from GitHub. Every square is one day of the year, and every green square is a day where I did something for open source. And I think this is what the internet calls, boy, this escalated quickly. So I challenged myself to do something in open source every single day. And this ended up being close to 400 days of doing something in open source. One of those squares over there in, I shouldn't be blanking on this, but one of those squares is the birth date of my daughter. She was born, and that's a thing to forget, my daughter's birthday. So she was born, and I was on the delivery room 2 hours after she was born when she and my wife fell asleep, and I accepted the pull request. So I was quite obsessed with open source. And it was around this time that the idea for Dove started to form. And when people ask, it happened a few times, when people ask my partner and me how we started working together, and what we always say is that we met on GitHub. So I met my wife on OkCupid, I met my business partner on GitHub. It was like a dating site for us. And it was perfect for us because we're a nonprofit building open source software. So it's where we met, it's where we do our work, and it's where we recruited our first employees. And we've been extremely lucky to have over 200 open source contributors donating code to the project. Anything from bug fixes to documentation and full features. And speaking of fortunate, we have an amazing group of advisors that have joined us in making Dev a reality, all the way from executives at top automotive companies like Dr. Alan Messer, who's the CTO of General Motors, all the way to people from throughout the industry. I'm not going to mention every single one, but I am going to mention two, and that's because these guys are superheroes. They're scientists, and the coolest kind of scientists there is. They're actually astronauts. So Dr. Scott Horowitz, who is a 4-time space shuttle astronaut, flew missions to the International Space Station, and then he was second in command in NASA. Also, George Zamka, who was the pilot on the space shuttle on one of its missions to the Hubble Space Telescope. So any day when you get to talk to an astronaut on the phone, That's going to make your day, your week, your year. These guys are, I said it, they're superheroes. There's no other word for it. So let's get back to what is DAV. Well, DAV stands for Decentralized Autonomous Vehicles. And in order to understand what that means, we're going to look at 3 questions. Why decentralized? What does it mean for a vehicle to be truly autonomous? And what do I mean by vehicles? So let me start with that. Throughout the talk, every time I'm going to say vehicles, keep in mind that we're not just talking cars. We're talking drones, we're talking trucks, we're talking electric scooters, electric bikes, boats, basically anything that moves people and things from point to point. And it's an amazing time right now for what it means to move people from point to point. Things are changing so rapidly. And the big one, of course, is autonomy. If we start to imagine the kinds of effects that autonomous cars are going to have on our society, it's easy sometimes to underestimate it, but it's not just about how you drive or how you don't drive. If you're looking 10, 15, 20 years into the future, this is something that's going to reshape our cities, it's going to reshape our streets, it's going to change how we work, where we work, how we live, and how our lives look. It's going to have amazing impact. So what does it mean for a car to be truly autonomous? So let's look at an example. Let's say I want to get from Zagreb to Paris, and I'm going to get in my normal car as a normal person and start driving west. At some point, I'm going to need to stop for fuel. So I'm going to look for signs for gas stations. I'm going to be able to understand what a gas station is. I'm going to be able to understand the pricing. I'm going to be able to talk to the person there. Even if they speak German or French or Croatian and I speak Hebrew, we're going to be able to make it work using a common language such as English. And even if that person does not speak English, we're going to make it work using hand gestures because humans are really good at talking to other humans. Our brains are just wired that way to understand other humans. The thing is, machines aren't. So let's try to imagine an autonomous car in the future trying to make its way from Zagreb to Paris. And when I say autonomous, I really should be doing giant air quotes around autonomous. Because if that car is able to negotiate city streets, merge onto the highway, pass trucks, all of that without a driver. But as soon as it runs low on energy, or as soon as it needs to have a tire changed, or anything fixed, or it needs to be even cleaned between missions, if it can't take care of its own basic needs, it's not really autonomous. It's simply driverless. And that's where DAV comes in. Our platform gives vehicles the tools to discover other vehicles around them, as well as users, services, infrastructure. And once they've discovered each other, it allows them to communicate with each other using a common language, agree to terms for services, and finally, it lets them transact with each other. And all of this happens in a completely decentralized, open way with no middlemen, no middle servers. It does not reside on our servers or anyone's servers. It's completely peer-to-peer. So let's see this in action by looking at the first project, the first POC we actually built. So we started this last January. So last January, we flew to meet Copter Express in Moscow. That's what Moscow looks like in January. So Copter Express are developing a drone called the Co-X Pelican. And the Pelican can deliver small packages over medium distances. And of course, they did the Hello World application of the drone world, which is delivering pizza. In fact, they were one of the first companies to do it. So when I visited them, we used an early version of the Pelican, which could take packages of up to 3 kilograms for distances of about 15 kilometers. So that's what we did. We developed a progressive web app in React that connected the users to the dev network, and we wrote a Node.js server which connected the drones themselves to the network. And now, once the two were connected, I was able to use my phone to send out a message, I need a package delivered, I'm here, I need it delivered there, it weighs that much. And the drones received that message and responded with bids directly. So the drones, I chose one of those bids, you can see the bids there. I chose one of those drones, signed a smart contract with the drone, transferring money from my wallet onto the smart contract, and the drone was on its way. The drone landed next to me, I loaded up the package, it took off, and once it delivered the package, the payment was released from the smart contract directly to the drone. Again, I had no prior business relationship with that drone. I just found it on an open network, and there were no servers involved in the middle for this transaction. So we essentially taught a drone who was able to fly from point to point how to sell its services in an open marketplace. We changed it from simply a flying machine to something that is able to, from a flying machine into something that is able to provide a service, from simply a concept into an application. And that's pretty amazing already, and the fact that we did it in JavaScript is just the icing on the cake. I mean, you'll remember how excited I was about having a pull request merged. Imagine how exciting it is to write a JavaScript code that makes drones fly. And as a side note, I really recommend that you try to do some kind of development that affects the real physical world. It's really easy to get started. There are prototyping boards that start at $5, $10, $15, like BeagleBone and Arduino and Raspberry Pi. And just having an LED blink in response to something from the internet is so exciting compared to what we usually do. Not that it's more exciting, it's just so different. So it's a fun exercise to do. Anyway, back to the POC. So it was pretty amazing, but in order for that drone to fly from point to point, it had to have the engineers manually tell it how to avoid power lines, how high to fly, how to avoid buildings. And that makes sense. There's no reason for every single company that develops drones to also develop the logic that determines how to fly and how to avoid buildings and to maintain maps. What we needed was a way for those drones to buy that on demand in real time when they needed it. So a few months after that first flight, we worked with a company in Nevada called Grad, and that company has detailed 3D maps of a lot of areas, as well as flight regulations and the ability to submit flight plans on demand to the FAA. And they were able to offer a flight planning service on demand through the network, and we connected them to the dev network, to the drones. And so now you had a drone that was able to offer delivery services and buy the instructions on how to fly without human intervention to complete that. So it was much better, but it still had one big problem, and that's one that affects most drones, all drones actually, and that's limited range. Now, range isn't something that's going to just get fixed overnight or anytime soon. I mean, we're going to see improvements of 2%, 5% in the battery life, but at the end of the day, it's chemistry. You can't just improve the battery 1,000-fold. So, and that is something that is required for drones to be commercially viable. So the next thing we did was we connected the service to the dev network, which was a network of charging stations. We worked with a company in Berlin called SkySense, and they manufacture universal charging stations for drones. You can see this one's an indoor charging station. Apparently they use drones indoor in warehouses, and this one's a rugged outdoor one. So we connected 5 of their outdoor charging stations to the network, and now drones were able to request charging service on demand, pay for those services, and continue on their way. And you can see that here. That's actually that first trial that we did with a drone requesting charging over the network. So that was a lot of words, a lot of different separate POCs we did, but let's kind of look at the big picture of what we're doing here. We took a drone that was able to take a small package from point to point, and we taught it how to sell that service in an open marketplace. But then we went and made it so much more powerful by teaching it also how to buy services as well. We taught it how to purchase a flight plan so that it could complete its mission without human intervention. We taught it how to purchase charging services so that it could operate for long periods of time without human intervention, again. And we even extended the drone's effective range without actually touching its battery. We took a drone that had a range of 15 kilometers and giving it an effective range of less than half of that because it always had to return to base. And we taught it how to hop from charging station to charging station, and we basically give it limitless range. So by taking a drone and teaching it how to sell services, but also how to buy services, you're turning it into something that is really, truly autonomous. And each new service, each new type of service that you add to the network, such as the ability for a drone to transfer packages to long-range drones or to short-range drones, or to work with robots that can deliver packages into residential buildings. So each new service that you add raises the power of everything exponentially. So I think you can start to understand the difference between driverless and autonomous, and what we're looking at to make things really, really, to open up this really exciting future that we're talking about. And it's not just about the ability to drive from point to point. What we need are common standards for vehicles to be able to communicate with each other. We need common standards for vehicles to be able to discover each other, and we need common standards for vehicles to transact and purchase those services from each other. We need to build an open marketplace for transportation services, which brings me to the final point. Why does it need to be decentralized? Well, today we have apps and websites and services that offer transportation in a completely centralized way with their user experience, their technology stack from A to Z. They control the entire experience from A to Z. And that means when you're using Uber or Lyft or Didi or Waymo in the future, using their drivers, their algorithms, their pricing, their route calculation, it's not open to outside innovation. We're seeing an experience that is completely closed, shuts off outside innovation, and not to mention costly. When you're taking an Uber, a lot of that cost goes directly to Uber. So I'm not saying Uber does not provide a valuable service or that they shouldn't be compensated for it. What I'm saying is that a closed system like this does not allow for outside innovation to drive down prices and increase the quality of the service. So we're looking to do things differently. What if instead of a centralized marketplace, we could build a decentralized one with no central players, with no servers, with no middlemen? What if instead of a closed silo where a user's entire experience is dictated by one company, we could break things apart? So what if a driver could connect directly to a passenger using a smart contract, and the two could include in that smart contract also other parties, such as an insurer or an arbitrator in case something goes wrong, and another service which will sell them some of the data required to complete the mission, and another which will buy data, and it will be up to both parties to decide which services they want to work with, and it will be up to those services to offer a competitive service at a competitive price. So decentralization is key to breaking apart those silos. And just to be clear again, we do not want to be that central point in the middle here. We are not trying to replace the silos with Dev. We're just looking to enable those connections between the different companies. Dev is a non-profit building an open source solution. It's structured as a consortium that brings together parties from throughout the industries to work on common standards. You can think of it as sort of the W3C of transportation, or at least that's where we strive to be. So Dev provides all of these basic tools, and I'm going to run a bit faster through it now. But Dev provides all of these basic tools to enable that marketplace to be created in a decentralized way. We allow for all the elements that are required, including discovery of services, communication, trust, and payments. And all of this happens on and off the blockchain. So the blockchain lets you have a persistent identity for each entity on the network. And that entity can be a driver, a passenger, an insurance company, or a car, or even a single component inside of a car that sells data. And you have a persistent history of the performance of each party on the blockchain with no need for middle servers. The blockchain also allows you to have smart contracts to govern those missions. And our own peer-to-peer network allows you to have decentralized discovery and communications between all the parties. And that happens off the blockchain to avoid the cost of the blockchain, which I'm sure people familiar with blockchain know what I'm talking about. So it avoids all of the costs of the blockchain while still offering the same level of cryptographic security and certainty, because every communication off the blockchain is signed with keys that are registered on the blockchain. So it provides this basic layer, this basic infrastructure required to build transportation services. And I think Priyanka from SAP said it best when she said, Dev is to the future of transportation what TCP/IP was to the internet. I'm happy someone else said it. I wouldn't feel right saying something that ambitious, but I think you can start seeing why the idea is attractive to both geeks like me who love to build things, but also to scientists who want to see a better way to build tomorrow's transportation, while still being a pragmatic approach, not just an anarchistic look at the solution or a naive one, but something that appeals also to the automotive companies. So just to wrap things up, this is what I said before. I spent the last few days here in Croatia with my family, and we were in Istria, and I actually gave this talk to a seagull. I've been practicing the last few days talking to a lot of inanimate objects, and when I was giving this talk, I was, again, as I said, I was really concerned that it sounds like I'm trying to sell something, and this isn't what it is. We're a nonprofit, we're not selling, we're not recruiting. What I want you to get from this is to think about autonomous transportation as so much more than just what happens about the gas and how the wheel gets turned and everything about the driving. It is about everything that happens around that. And that's where the really interesting innovation and the things that are really going to reshape society are going to happen. And I think us as developers can choose to work in companies like that or start companies like that. And when we do, I think we should choose to work in companies and try to form our companies so that they work in a more open way, in a way that fosters innovation and cooperation between different parties. Again, this isn't just me being an anarchist. This is a pragmatic approach for more innovation, for more commercial success for those companies, because each new service you add that is able to work with everything else around it builds exponentially with everything around it. Yeah, thank you.
All right. Thank you, Tal, for the great talk. I assume we have some questions for the dear gentleman here. 1 second.
Hey, I really appreciate your talk and the effort and the initiative and the good intentions of DAV. I think that's really worthy of applause. My question is, because I assume DAV is just becoming a thing, right? It's growing. So are there measures in place to protect the decentralized nature and the open nature? Because, I mean, as things grow, usually, venture capitalists step in. We all know what happened with NPM, right? And so my question is, what are the measures that DAV is taking to protect against such things?
Okay, so we took the hard way, the hard approach to building things. We actually formed as a non-profit foundation with an independent board governing the foundation, and it's a non-profit registered in Switzerland, which was not the easy way to go about things, but we felt it was key in order to convince, I mean, you have to work with the biggest companies in the world. You have to work with the Volkswagens and the Fords, so you can't just do whatever is easiest. You have to form a really stable foundation, and yeah, that's what we did. It included a lot of hardship to be able to work with FINMA, the Swiss regulation board, and to make sure everything is done right. And it's a lot more costly, obviously. There's a lot of lawyer costs around that, but we believe it's key. And that having a board overseeing everything we do is key to that and to gain trust. But I think in the long run, this is something that, because of the decentralized nature of the blockchain, this is something that even if we go rogue, this isn't something that we can control, because once we release the contracts to the blockchain, they're immutable, we cannot change them. The code, if we're doing something malicious, anyone can just fork it and decide to build their own network. I think the strength in the network is in the number of different people who use it. So if we go rogue, again, as I said, it'll just lose all its value.
Hi. So you were talking about how you would work with a lot of companies, but decentralized, and you mentioned like Uber takes a big cut, for instance. Like, what would be their motivation to go decentral? Like, what would be their motivation to accept this system of decentralized stuff?
So I think companies like Uber are the last ones to adopt this, and they will be kicking and screaming as they adopt this, because we're here to disrupt that model. But that model has to be disrupted. I always equate those companies to things like we had. When I was a kid, we didn't have the web. We had services like CompuServe and Prodigy and AOL. You would call up to them, and they would control your entire experience, their email, their weather and news and everything. And only once we had open standards did we have innovation, an explosion of innovation that was the World Wide Web. And I think the companies that will adopt this first are the companies that have the most to gain, and that is the car companies who are looking to work throughout the industry, and that's something we've been hearing from them as well. But the ones who are holding onto power as aggregators of different services are the ones being disrupted here.
Hi, thank you for the great talk, and it's a very interesting topic. As you said, you have 2 superheroes on the board, so I'm just curious, how much is their experience from the space program affecting your project, and how much is the space technology, the things like all the robots that we send to the space, how autonomous they really are, and how much of that experience are you able to bring into your project? Thank you.
Yeah, it's a great question. So, yeah, these people are astronauts, but as I said, they're scientists first, and they have their own fields of expertise. So, for example, Dr. Scott is one of the foremost experts on drones. So he really knows his field of drones, and he really knows how things work. So he can offer his expertise on this. We are not using their help for space, at least not yet. And our other astronauts, like, yeah, it's sexy to say you have astronauts on the team, but what they're actually giving us is their field of expertise. And George was in one of the top executives at the American Federal Aviation Administration, and obviously one of the biggest challenges for drone flights is regulations. And so we have an insider look into that.
Hi, you mentioned Skynet, you referenced Skynet in the title, which actually brought me to your talk. Do you think it will go hostile like Skynet from Terminator, or is this some other Skynet? Thank you.
Definitely Terminator. That's why he introduced me as Miles Dyson. Yeah, I think what we're doing is we're giving, famous last words, but we're giving machines superpowers. In a way, we're turning them autonomous so they don't need us. So we always joke that we look over our shoulder for time travelers coming to stop us. Yeah, that's definitely what we had in mind.
Hi, thanks for the talk. As you said, Dev is more concerned about building standards and linking technologies together. However, since you have insight into the making autonomous vehicles field and everything like that, what are, I would say, predictions or hopes that you see? When would we, let's say, see drones as something, as you've described them in your example, something that would be available to an average customer in an average size town? When would you say that we could expect that? 20 years in the future or something?
I don't think I'm going to be foolish enough to make a prediction like that on camera unless I'm very drunk. But I think it's something that's going to happen, not like all or nothing. We're going to see specific areas where we're going to see automation happening, and that might be in trucks doing long-distance deliveries without human intervention. Even if once they get to the city, a driver takes over, we're going to see it. We're already seeing it with the drone deliveries of drugs in different areas. We're seeing deliveries of blood packs in Africa happening with drones every single day, saving lives. So it's going to start happening, and slowly it's going to come into our lives. And it's a question of when will we humans accept that if an autonomous car is only 100 times safer than a human driver, can we accept that an autonomous car kills one of us? And we're not there yet. We're not ready to accept that yet, but it'll come because they're going to be so much safer, at least in most situations, than human drivers. because we're really bad at it.
Hi, thanks for the great talk. One not so sexy question. So how are the drones paying their taxes for profit and salary?
So that is actually a field that's really changing really fast, and you actually have to report, I'm going to answer it seriously, you actually have to pay taxes on cryptocurrency earnings, just like you do other earnings. And we're actually very lucky to have the former general counsel of the Ethereum Foundation as our general counsel. And she knows that's the kind of stuff way more than me. And it's not as interesting to me as writing code.
Thanks for all the answers. I see that there are additional questions, but we have to cut this because we have the next lecture coming up. So Tal is probably going to be here in the hallways. You can catch him up for coffee. I assume that you will be open to talking to people. Please give the man a round of applause.